welcome to Algorithms or Us. You can visit us at the URL listed right here. So this site is for helping users learn about data structures and algorithms. Our target audience is first-year students learning about data structures and algorithms. Our application aims to help students grasp these concepts by providing side-by-side visual aids and high-level descriptions. By targeting first years, we hope to build the foundation for later in their studies and their future career. So now I'll guide you through two scenarios. Scenario 1 is that a user wants to use our website to learn more about depth-first search using Python. So here on the home page, the user will navigate to Graphs. Then within Graphs, they'll look at the algorithms, and they'll be able to see depth-first search. So they'll select that. And then the user will see all the data that they can perform the simulation on. So let's say they select tree A here, which is a binary tree with the depth of 4 and 12 nodes. So once they've selected that, they can begin the simulation. So you can see here's our tree. And first of all, for depth-first search, we have to pick an element to search for. So say we pick the leftmost tree node, H, which is listed right here. So we search for H. And as the simulation goes on, you will be able to see the variables being updated, a color highlighted data structure to show the progress of the algorithm, a high-level English description of what is going on in the current line of code, and of course the code which is highlighted for each line. Also, you're able to switch the language here to Python. So now let's advance the simulation by clicking the next button. And as you can see, it found the element as it returned true. And that element is listed in purple here because it was found. So now let's navigate back to the home page and we'll go through scenario number 2. Scenario number 2 is that a user wants to prepare for a test on the tree data structure by going over practice quizzes. So first they'll navigate to Graphs because tree is a restricted form of graph. Then they will navigate to trees. And now here on the trees page, they're able to select quizzes. And the quizzes will be filtered depending on what page you are. So here in the header, you can see the data structures tree. So all the quiz content that we select here will be on trees. So now here are all the tree questions, and a user can select any of these questions. So let's select the first question and say the user selects option 2 and they submit that. Now that was incorrect, and you can see here that it gives you the correct answer listed right here. Okay, so that's it for the simulations. What is unique about Algorithms or Us is that it's a one-stop shop for understanding algorithms, and it has many visual components side by side. Also, the code switching button is very unique to our application. If we had more time, we would restructure the site to require fewer clicks to navigate through the site hierarchy, expand the database to contain a wider variety of data sets to select, and to implement more algorithm simulations. As you can see on the graphs, their algorithms have not all been implemented, such as the shortest path and the minimum spanning tree. Now on to our system architecture. And so within the GitHub folder, in our project repo, all of our files are listed within my site. So in our system architecture, we use Python with the Django framework, HTML, CSS, and JavaScript in order to create our modules, templates, and databases. We use the Django framework to create a module for each data structure or major feature that required its HTML page, such as quizzes. So all of the models and views will be contained within each of these folders here. Also the databases. And each module has a separation of the HTML templates folders and a folder with its class. So you can see inside the templates, each of it has its HTML files, the templates listed in here, such as for binary trees. You can see the main template, which all the other trees inherit, to reduce repetitive code, as well as all of the algorithms and the index that relate to binary trees. For linear linked lists and quizzes, we used a 3-tier architecture where the HTML template only held presentation relevant material, and we stored our logic in the models files to query the database. For other data structures, we use a simpler 2-tiered architecture with a JavaScript pseudo-database that held JavaScript classes that were inherited by each data structure within the same hierarchy, such as graphs, trees, and network flows. Here you can see the database, and right here this will be used for all graphs and everything lower in the hierarchy. So right here you can see the root node, and this is the definition with the value, the children. It will also contain information about the type of tree, such as if it's a binary tree or if it is just a graph. So it'll also have the nodes and the depth, so you can decide what you want to traverse when you see the data structure. We also have the definition of a node with its value, parent, and child. And as you scroll down, we can see instantiations of the trees and the nodes. And all of our data, we store it together by collecting all of our trees, and you can see all the roots for all of our trees in here. And that's how we access the data. This simpler architecture allowed us more control over the data, the ability to easily work with object-oriented data, and it had less setup required.